Right, good morning, Year 8. So today what we're going to be doing is looking at how electrons are arranged in atoms, okay? So, obviously we wouldn't do the starter test for the key words, but hopefully you are familiar with these words now. They're all from last lesson. So, what do these words mean? Okay, so in case you're not clear, proton is a positively charged particle found in a nucleus with a mass of 1. Neutron, neutrally charged, or sorry, neutral particle, also found in the nucleus, also has a mass of 1. Electron, negatively charged particle, almost no mass, like virtually no mass, like tiny, so negligible, we would say. Orbits the atom like this. Atomic number is the number of protons, or sometimes, and most of the time, the number of electrons as well, but not all the time. And the mass number is number of protons and neutrons combined. So, firstly, what I'd like to do is maybe just quickly copy this up, and can you describe this atom? Okay, this is a model of what an atom looks like. So pause the video quickly and do that now, please. So obviously this isn't quite to scale, but a good description of this would be an atom has a nucleus at its core, at its center, with positive protons and neutral neutrons clustered together, with electrons orbiting the atom in shells. Okay, and basically what these electrons do is they orbit so quickly it's almost like a blur. They almost appear as solid lines. Okay, so you've got a nucleus with positively charged protons and neutral neutrons, and then negative electrons orbiting the outer edge. I should note that virtually all the mass of the atom is in the nucleus, okay? Even though most of the atom, or most of the space, is like this. So if I was to say, for example, draw a circle around it, you can see that that's sort of what an atom would look like. There's your nucleus, and actually it's much, much smaller than that. It'd be like a dot in the middle, okay, because this isn't drawn to scale. So most of the atom, rather surprisingly, is actually just empty space, which is a bit bizarre when you think about it, but it is true. Anyway, today what we're going to do is we are going to look at how these electrons are placed in these orbits around the nucleus. So today, all of you should be able to describe where electrons are found in an atom. Most of you will be able to explain how electrons are arranged in different atoms, and a few of you draw electron configuration diagrams. So this is quite advanced stuff. So, very quick reminder. In the nucleus, you've got protons and neutrons. Now, protons are positive, which means the number of negative charges must be the same to balance them. So we've got 1, 2, 3 protons, which means we must have 1, 2, 3 electrons, and we do. Protons are positive, electrons are negative. Okay, so however many protons you've got to have the same number of electrons. Now, you'll also notice that these electrons are in these shells, and how they are arranged in these shells depends on what kind of atom it is, but also how many electrons they have. Okay, so it might be worth drawing this as a very first example. Okay, so quickly pause the video and do that now, please. Okay, welcome back. So for the second part of this lesson, what you are going to need is a copy of the periodic table, either in your revision guide or you can just pull one up on the internet. Have it to hand at some point. You don't necessarily need it right now, but you will need it in a little while. Right, so firstly, in assignments, there is a video link. It's about 7 minutes long. The first part, you've pretty much got most of that information about protons and neutrons. The second section of the video is about electrons, so it's definitely worth making notes. If you need to, pause the video and replay it to make sure you get notes. I'm probably looking at 5 or 6 bullet points, okay? So pause this video, go into assignments and watch the YouTube link, and then we'll come back. Right, so hopefully you've got some information now about how electrons and atoms are arranged. Okay, so they're arranged in shells, or what you'll sometimes be heard as energy levels. Okay, and there are basically rules for how many electrons you can have. Okay, so in the first shell, closest to the nucleus, so there would be the nucleus in the middle, just there, you can have a maximum of 2. Now, you can have 1, but basically you can have a maximum of 2. Okay, so only a couple of that, only one atom, in fact, has 1. Okay, which is hydrogen. The rest have 2. Right. Once this electron shell is full, you then have to go to the next shell. Now, the next shell can have up to 8. So 1, 2, 3, 4, 5, 6, 7, 8. And once that's full, once that's got 8, it's considered full up. Okay, so once it's got 8, you then have to go out to the next shell, which again can have up to 8. Okay, so there are various rules, and if you follow those rules, you should be fine. Okay, so we're going to do an example. We're going to start with a reasonably complex one. Okay, so we're going to start with sodium. Okay, so there's the sodium nucleus. So the first thing I'd like to do is find sodium on the periodic table. Okay, and we need to know how many electrons we are going to need. So sodium has the atomic number of 11, which means it has 11 protons, 11 positive charges in its nucleus, which means we're going to need 11 negative charges. Okay, 11 electrons. So this is, I'm just going to draw you, this is going to be my electrons, just going to do it in blue, there we go. Right, so there, that is going to be an electron. Okay, so, okay, welcome back. So I've drawn in my electrons, there they are. So where do we actually put them? Right, so the first, we know we need 11, so we can have 2 in that first shell. 1, 2. There we go. Now, that is now full, so we need to go to the next shell. Okay, so we've got 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Now, if we have a look, 1, 2, 3, 4, 5, 6, 7, 8. Right, so 2 and then 8. So this shell is now full, but of course we've still got 1 electron because you've got 11 positive charges. You need 11 negative. So this one goes in the next level. Okay. Now, you will be asked, what is the electron configuration? The case of sodium, we've got 2 in the first shell, so 2, comma, then 8 in the next shell, 8, and then we've got 1 in the outermost shell. The electron configuration for sodium, 2, 8, 1. Okay, so hopefully that makes sense to you. Okay, that's an example there for you. So what I'm going to get you to do is I'm going to get you to draw the electron configuration for the first 20 elements. And it's got to look something like this. Okay, sodium is in there as well, so you've already done that one. Okay, so a couple of rules to remember. The first shell can have up to 2. The second shell can have up to 8. But once it's like that, it's full. And the third shell can also have up to 8. Okay, but remember, they don't have to. They've got to have the same number of electrons as the proton number. Okay, so that's your example. This one is oxygen. I'm going to leave you to do that one. So in assignments, there is a copy of this sheet. What I want you to do is draw the electrons, or the electron configuration for each atom. So first one has 1, okay, hydrogen, and then go through all the other elements. So what I'd like to do is essentially write down what the element is. So in this case, next to it, once you've drawn in your electrons, let's make that a bit smaller so you can actually fit it in. This would be, oh, actually, see what, let's do the one we've already done. So this is sodium. So next to it, you can write sodium, because that's what it is. And so the electron configuration. And you might have to squeeze it in wherever you can. I'm just going to have to sort of squeeze it in there. 2, 8. Okay. Yeah, just sort of squeeze it in where you can, like that. Okay. So that would be sodium, because we know it had 11. All right. So give that a go. That'll probably take you about 15 minutes to do that, because you'll probably need to refer to your periodic table. And then as an extension, okay, choose one other random element on the periodic table and try and do the electron configuration for that. Okay. If you do something quite difficult, something high up the periodic table, you might need to choose something, you might need to do a bit of research into what it is. Okay. Right, so that'll probably take you about 15, 20 minutes to do that, because it's quite a challenge. So if you can't print off the sheet, just draw it into your book like this, and then just draw the electrons onto the concentric circles like this to show the shells. Okay, you don't need to draw the protons and neutrons. The dot represents the nucleus. Okay, so pause the video, off you go. Okay, so welcome back, and one last thing I would like you to look at before we finish. Once you've drawn out all the electron configurations, okay, I want you to tell me what you notice about where the atom is in the periodic table and how many electrons it has in its outermost shell. Okay, I want to see if anyone spots a pattern. So here's what you're looking for. What's the link between the electrons in the outermost shell, or the number of electrons in the outermost shell, and where the atom is on the periodic table? If anyone can spot that, post it up and we'll start going through it again next lesson. Okay, right everyone, good luck, and I will be online as always to help you out.